So what is this exponential equation that I'm trying to deal with? It is f of x equals a times b to the x. A can be negative, but b has to be positive, and b can be a fraction, a can be a fraction. Neither one of them can be zero. Okay, so let's take a look. The claim is, first of all, if you're given an input of 0, it automatically gives you what a is. So let's just see that. X is 0. So just to make a big deal of it, I have a times b to the 0 being 5. Well, what is b to the 0? As long as b isn't 0 itself, it's the number 1. Oh, so a is 5. So again, the y-intercept tells you a. So for problems 2 and 3, for instance, we have to do a little bit more work because we won't know a or b immediately. The second problem, x is 2, that goes up in the exponent. So a times b to the 2 is 245. Let's plug in the number for a. Let the calculator do the division. Oh, look, it's a nice perfect square. So b is 7. And we don't have to worry about plus or minus because, again, for these exponential functions, we're forcing b to be a positive number. So my function is f of x is a times b to the x. Okay. All right, so what do we have here? A times b to the 1 is 10. And then a times b to the negative 3 is 2 over 125. Well, that's special. Let's divide. It'll get rid of a. Okay. Just don't forget when you divide by a fraction, you flip and multiply it. Calculator says this is 625. And how do you deal with these? We subtract exponents. Or flip b cubed up into the top. Either way, you have b to the 4th is 625. Guess a nice number. B is 5. How do you tell that? You can do 4th root on your calculator, but you can also just say, okay, I bet it's a small number. Let's try like 15. No, 15 to the 4th is way too big. Okay, so let's try another number that ends in 5. How about just 5? That's how I sort of guess at it. So to get a, remember that a times b to the 1 is 10. So a times 5 is 10. A is 2. And again, I don't care if you write f of x equals or y equals. Let's see, a times b to the x. There we go. All right, let's take a look at this one. A times b to the negative 2 is 1 over 80. And a times b to the positive 2 is 16/5. My suggestion is put the bigger power of b on top. It at least help gives the numbers from, remember b to the negative 2 would mean flip b squared, and I don't want to deal with that. So a times b squared, 16/5. We're going to just divide that by a times b to the negative 2, 1 over 80. So canceling out the a's, I have b to the 2 minus negative 2 is 16/5. Flip and multiply. I'll write that in blue. Times 80 over 1. Calculator says that is 256. So b to the grand total of 4 is 256. And again, small number. Try 8. No, way too big. Try 4. Oh, 4 is good. And then a times b squared is 16 over 5. So a is 16 over 5. Don't divide by 16. Multiply by 1 over 16. Oh, look, the 16s cancel. We have 1/5. Don't forget to write your final answer. Y equals a times b to the x. And put a box around it if it's not the last thing. All right. Looking at this, if you have a picture, the one on the problem set goes through nicer numbers. I think it goes through like 2, 6 or something. But 0, 2 means a is 2. Okay, and then it says it goes through 2, 1.28. So what's that? A times b to the 2 is 1.28. Remember, a is 2. Ask your calculator what 1.28 divided by 2 is. 0.64. Does that have a nice perfect square root? Oh, yes, it does. So it's f of x or y equals a times b to the x. All right. Remember that if you have a table or a graph where you know what where you know what the value at 0 is, that tells you what a is immediately. Okay. If x is 1, we have a times b to the 1 is 4. B is 4 over 16, which is 1/4. Okay, we can check. Oh, yeah. Notice that if you're going up by 1s, you're multiplying by b each time. So my function is a times b to the x. I like to put the b, if it's a fraction, in parentheses so you square the whole thing and not just, or take the x to the power of